3, 2, 1.
What happens when you create the ultimate grease fire?
That is live, for sure.
Turn an empty soda bottle into a dry ice bomb.
Wait a second, has that gone?
And go on a magical mystery tour
Oh yeah, very different.
into the exotic world of soap bubbles. If you want to know, you've got to get warped.
Uh-oh.
Take two guys whose slow-mo cameras can stop the world in its tracks.
I'm gonna run down there and catch all the action. Good luck. All right. Matt, you ready?
All right, Greg, I reset this camera. We're going to take a look at your takeoff this time.
Add a high-tech laboratory where anything can and will happen.
Oh boy.
And some of the world's wildest talents. What happens? Time warp. When it comes to the four main food groups, we're all pretty clear as to their identity. Deep-fried dough, deep-fried potatoes, deep-fried meat, and a newcomer, deep-fried giant entire turkeys, cooked in giant jumbo-sized deep fryers, filled with massive amounts of oil. But there's a dark side to these foods besides expanding waistline potential.
3, 2, 1.
If you are not careful, they can kill you. Now, we go inside a grease fire and find out that oil and water not only don't mix, they actively despise each other.
I think this is a really bad idea. 3, 2, 1. It was a really bad idea.
Let's start with the basics.
I think we got it.
A shotgun marriage of oil, water, and flame presided over by Deputy Fire Chief Jay Fleming.
Well, that's why we don't want you to put water on a grease fire. This is the method that most fire officials recommend. Cut off the oxygen, and that puts the fire out.
Well, that's good to know.
What you want to do, though, is turn the gas off right afterwards. Because if you don't, and you took the lid off, once the oxygen reaches the fire again, it's just going to go off. So you put the lid on, turn off the heat, walk away, call the fire department.
Much better than our method.
I think so. Let's look at this on high speed.
So it's like there's a mixture of steam cloud inside the combustible vapor cloud. That's an amazing shot.
You said it, Chief. By time warping the cooking pot at 170 times slower than normal speed, we see what looks like a volcanic eruption. Here's where we usually tell you don't try this at home. But in this case, thousands accidentally do with horrific results.
So all of these little dots that we see that look like little fireworks, that's the oil that's been shot out by the steam.
Yep,
and igniting.
It's vaporizing and igniting.
Unbelievable.
Yeah.
To really see what's happening when these two liquids meet head-on, we need to look inside the pot. Once again, we'll pour water into oil heated to its ignition point. And stand back. Way back.
Let's do this. 3, 2, 1.
Blink and you missed it. What makes the entire area ignite so quickly? It's worth a replay.
All right, so there goes the water in.
The water expands almost instantaneously.
It's amazing to see the water expand in
Expands
the oil.
so fast. This whole thing is, maybe a 50th of a second for it to reach all the way to the other side. And now we have this shower where it looks like there's no worry about a fire. There's water everywhere.
And it ignited.
And then it ignites.
As it boils over, cooking oil comes in contact with the flame under the pot. Watch again.
So as it's overflowing, there's a lot of water droplets, but there's also a lot of oil too. Now remember, that oil was already heated to its flash point. Now we didn't ignite it in the beaker, but as the oil comes down at its flash point and it hits the burner,
Boom.
that's when it
It's
ignites.
just waiting to go off.
Yeah.
Matt, you set?
We're good to go.
Now the ultimate simulation. water hits vat of oil.
All right, good to go. 3, 2, 1.
Whoa!
Oh my God.
This is what would happen if a frozen turkey, or anything large and frozen, hit a vat of boiling oil. It's not a pretty sight.
So this is the problem with the frozen turkey. They drop the turkey in, causes this steam explosion just like we had before, and you can get this situation.
Do this at home, and those grease droplets could come in contact with the heat source. You could be engulfed in flames, and your house burns down. You've been warned.
Looks like one of those flamethrower type explosions you see in war movies with the special effects, and people can create those in their backyard if they're not careful.
And this isn't just a flame growing. This is an explosion. I mean, this happened in fractions of a second.
I mean, we were a good 20 feet away, and it was almost painful if we had been exposed for much longer.
Yep.
We're not used to it like you are. It was painful.
So what have we learned? Deep-fried food tastes real good. Oil, water, and fire don't play well together. And never, ever, ever deep fry a whole frozen turkey. Now, Jeff and Matt aren't finished mixing weird stuff together.
I think we're going to have one of our patented kabooms.
And there's even more to blow up when Time Warp returns. Welcome back to another case study of things you should never try at home.
Okay.
Need a reminder?
3, 2, 1.
We just showed what can happen when oil, water, and fire mix.
Whoa. Oh my God.
That was amazing. I mean, 1 cup of water and we have a 20-foot plume of flame.
But there are other ways that ordinary household items can explode. And by ordinary, we mean ordinary.
If you've ever seen a Halloween punch bowl before, you're looking at the delightful mist of dry ice.
Cool.
Usually we slow things down, but in this case, we're speeding things up. Note the ice cube on the left melts into a puddle of water. The dry ice on the right evaporates into thin air. But what if that dry ice had no place to go? Say, if it was trapped inside a bottle.
The dry ice is just solid carbon dioxide. It freezes at about 107 degrees below 0 Fahrenheit. Now that water is at room temperature. That's almost 200 degrees difference from the dry ice. Right. So it melts really quickly, but carbon dioxide skips the liquid and goes directly to a gas. And because it skips liquid, it can have extremely explosive results.
Now, I know what you're thinking. Why is Jeff cutting up pieces of dry ice on a bandsaw? 3 reasons. 1, preparing for an illuminating scientific demonstration. 2nd, dry ice can and will burn your fingers. And 3rd, an extra lean cut of dry ice is easier to cram inside a bottle.
As soon as this converts to gas, it wants to take up about 1,000 times the volume that it currently is. And so we're gonna fill about half of this, but it's gonna wanna be 500 times the size of one of these bottles. You can guess what's gonna happen then.
Yeah, I think we're going to have one of our patented kabooms.
Well, we like kabooms, right? So it will probably go kaboom.
Matt and his high-speed cameras are now set up to capture every millisecond of explosive force from the bottle as the carbon dioxide gas expands.
We've got eye protection already. I think we're good to go. I'm just gonna add some hot water to accelerate the reaction.
I'm going to accelerate my exit. So when you cover this, we leave.
Ignition,
Ready? Yep.
Start off.
countdown.
Goodbye.
Yep. No, it's gonna happen.
Did we mention this could just be a theory?
No! No! All right, well, I hope you got that.
Well, the triggers were set. We should have it. I just have to restart my art first.
After an on-set defib, we played back our footage at 5,000 frames per second.
Wow. Even that is so fast. That's less than 1,000th of a second.
It literally propelled right at where we were.
Yeah, that whole thing took less than 100th of a second for it to move several feet. That thing is going amazingly fast.
Now we're showing you this a few times so you know what it looks like, so you never, ever feel like trying it yourself. Dry ice or not, this is a real explosion, and not something anyone should mess with. Just how destructive this can be is demonstrated by our next experiment.
We're gonna do 3 bottles now. We're gonna take it up about 5 notches right now. We're gonna put 3 bottles in the water. They're gonna be surrounded by a ton of pressure.
So essentially, we're making a dry ice depth charge here.
I would say that's exactly what we're doing.
Pop it in.
Pull that guy down.
All right, I'm out of here. Come on.
Much higher. That's good.
And what's gonna happen?
Well, what's gonna happen, obviously, they would naturally explode at different times, right? However, those are so close together that once one of them creates that pressure wave, it's gonna definitely cascade to all 3. There's no bubbles escaping. So this thing is building up pressure. This could be bad. Yeah, let's give a...
I command you. They're
Oh.
starting to expand.
Oh my God.
Okay.
Okay,
Hit the cameras.
Cameras are okay. We're good.
Real smart, guys. Only 1 bottle burst, and the other 2 are sitting in the middle of our extremely expensive equipment.
Wait a second. Has that gone?
No, I don't know.
Those
Yeah,
guys are,
keep the set
I don't
clear?
think those have gone yet. So
they have.
keep some distance. Let's set those off manually. There's the other one is live as well.
Guys, here.
What?
I want to do it.
There he goes.
If anyone has any problem with this, speak up now.
Stay back, stay back.
See why nobody should try this at home?
And that tank is 1/8-inch thick steel. There's no way you can bend that with your hands, and that thing looks like
Being
tinfoil.
thrown around like a rag doll. And essentially, that's 1 bottle.
It's totally unexpected. I really thought that the first one would definitely trigger the ripping of the other 2.
I can't imagine what that would have looked like if all 3 went at once.
Viewed at 10,000 frames per second, 1 bottle bomb was plenty, thank you.
That is an amazing shockwave. You can see it starts out pretty asymmetric. It has to move the mass of this thing out of the way, but then it's pretty much a sphere. It's going out as fast as it can. That carbon dioxide wants to expand to something probably the size of a swimming pool.
This demonstrates the law of intended and unintended consequences. Ordinary items, when put together in the wrong way, can become devastating.
This thing is destroyed, man. That is 20 feet away from the tank.
This was here.
After all this mayhem, we can use a little break. You want to try our next story at home? Go right ahead.
It just looks like it's there and it's gone.
Yep, soap bubbles. But soap bubbles like you've never seen before. When Time Warp returns. There is no pastime too innocent that doesn't attract professionals. And Keith Johnson is one such professional. Keith Johnson is the bubble artist, and he's got a great gig. His full-time job is all about blowing huge bubbles for kids and maybe sneaking in a few scientific principles along the way.
I was the first bubble artist in America to get a government grant to research, create, and perform a soap bubble show.
Paid by the government.
That is correct. These are your tax dollars at work.
You know, considering some of the things our tax dollars are spent on, bubble blowing seems like an efficient expenditure. It does have that cool thing going for it.
I just think it's fascinating the way they move, the colors on the outside, the way they shimmy around. They're the funniest things I've ever seen in my life. Seems like that they're really wobbly and unpredictable, but they follow along with some of nature's basic laws.
There is a method to the bubble madness that unlocks some pretty basic laws of nature. Law number 1, they act like a prism, reflecting the basic colors of the universe.
White light coming in is actually composed of all the colors in the rainbow. And based on the thickness of the film, all the different colors refract off in a different way. And so just like a prism, we get the whole spectrum in every bubble. The amazing thing to me is that when you look up close, It looks like bubbles are clear, but there's so much color going on.
That is correct. It's every color of the rainbow. I like to think that the colors are a map showing you that the film is thick in some places and thinner in others.
Law number 2. Bubbles want to be round, not get around. When we warp one of Keith's monsters, it looks like a drunken amoeba, but once let go, it wobbles its way toward becoming spherical.
Go for it.
All right?
When we get warped, this basic bubble yearning is revealed. They long to become spherical, and their ultimate demise is all part of the great scheme of things. But unlike death and taxes, there is a way of prolonging the inevitable, and that brings us to law number 3. Bubbles are wet and like to stay that way.
Now, anytime you touch a bubble, it pops, but it seems like you have no problem using any of these tools to mess with bubbles without them blowing up.
The rule is dry things pop bubbles, but wet things don't. If you wet your hand, you could probably put your whole hand in there.
All right, I'll try it. Oh, yeah. Very different.
The impossible becomes possible. The soap bubble molecules bond with the same molecules coating Jeff's hand, so he's more than welcome to come inside.
But as soon as my fingers dry, though, big difference.
A dry speck of dust enough to pop the bubble.
It's amazing how delicate the bubble really is. Now, as a bubble expert, have you had a chance to see one of these pop?
It happens so fast, I've not. I'd love to see it.
It's a couple thousandth of a second. Well, Matt, all right, why don't we set this up?
Keith has had a chance to show off to us. Now it's our turn. We're going to show him something he's never seen before. A bubble bursting at 5,000 frames a second. A simple ball bearing is the projectile of choice to accomplish the task.
It's coming down. Ready.
At normal speed,
How was that?
it looks like the bubble just explodes. But is that what's really happening?
So there it is.
It's pretty amazing.
You think of it as one event, instant event, but there you could really see the terror.
You never think of it as a directional event. It just looks like it's there and it's gone.
Watch the bubble burst again, even slower this time. There's some complex science going on here. Surface tension holds the soap bubble molecules together, while the air inside the bubble is forcing them apart. When the bubble begins to tear, soap molecules shoot out in all directions as tiny droplets. Okay, as we bid farewell to the wonderful world of bubbles, we recruit some volunteers to give them a last kiss goodbye. So there you have it, bubbles. Everyday psychedelic miracles of physics, the time warp way. When we come back, we'll show you the perfect way to end a dinner party. Next on Time Warp.
Well done.
Well, in this episode of Don't Try This at Home Theater, aka Time Warp, we've pretty much turned a wide variety of ordinary items into spectacular demonstrations of sublime art. Cautionary tales. Or the ultimate definition of the word oops.
Okay, the cameras.
Now for our grand finale.
So if we can get some lights, and I can get camera,
You got camera.
I'll try to provide a little action. Always wanted to try this.
We could demonstrate Newton's first law of motion and the static versus kinetic friction and the integrated impulse over time, but this is more fun.
Very nice. That was awesome.
Thank you.
I'm thoroughly impressed, except for you went the easy way. You should go lengthwise.
But you're not impressed enough. All right, well,
I'm sure that I can do it
let's
lengthwise.
turn this around.
Okay.
But if we're going to turn the table, you know, the things on the table were clearly too easy as well.
No problem. Bring it on. Let's
Okay.
set it up.
Absolutely. You're ready for this?
Piece of cake.
Yeah, I think you're wrong.
It's not going to be a problem. Newton's law, blah, blah, blah.
Okay,
I
go
got
for
this.
it.
You ready?
Yep.
Here we go. That was cool.
Matt made a fatal and, yes, deliberate mistake. He pulled up on the cloth. That caused it to actually lift the objects from the table rather than sliding beneath them.
Well done, man.
Right way and wrong way. You know, wrong way does look like more fun. Oh, and one more thing.
Don't try this at home. Everything we do is supervised by professionals.
Seriously, don't try this at home.
Something you want to see warped? Check us out on the Discovery Channel website, discovery.com, and the warp you see just might be your own.